Okay, I wanted to talk to you today about AI agent design principles and the common ones you're going to see out there, as well as walk you through a code example of a really simple design. This is so you can better understand what frameworks like Crew AI, Langchain, small agents, and more are doing underneath the hood as part of your developing AI agents. So the most common design for an AI agent is using this ReAct framework or methodology. And so it revolves around this reason plus action type methodology. And really, you're going to send a prompt to the LLM, then the LLM is going to have thoughts about the question that was asked to it. Then it's going to take certain actions, typically in the form of function calling or tool calling. And then it's going to get the results from those actions and feed it back to the LLM as observations. And then if it has more thoughts, then maybe you'll call out and do more actions and then have more observations. And once it's fully satisfied, then it will return the answer back to the user. So pretty simple. And let's take a look at this white paper here. Was released a little while ago, and here's an example of it. This is using the hotspot QA test, which is kind of one of those benchmarks they use to determine how good an AI is at answering questions. And we can see here that the question is, aside from the Apple remote, what other device can control the program Apple remote was originally designed to interact with? And then, if you ask this to a straight up GPT, like maybe like a GPT 3.5, it might say, iPod is the answer, which is incorrect. And then if you ask it to say, hey, think step by step before you answer, you're more likely to get the right answer. But still here in this example, you can see it lists a few examples like iPhone, iPad, iPod, but it doesn't give us exactly the right answer that we're looking for. And then, if we ask it to kind of act, right, but not really reflect on its own observations or have independent thoughts about those, then it gets a little bit closer here in this third attempt. But then when we get this full methodology where the LLM has a thought, so here it says, I need to search Apple remote and find the program it was originally designed to interact with. And then the act is search, like maybe it does an internet search, a DuckDuckGo search, something like that. And then the observation is what it found out, maybe on the Wikipedia page, right? The Apple remote is a remote control introduced in October 2005 by Apple, originally designed to control the front row media center program. So then it's going to have a thought about that. It's going to say, hey, what is this front row media center? So then it does another action. It searches the internet for that to find out more information about it. And then it observes what that is and just kind of iterates in this loop until it gets a really high fidelity answer and then returns it to the user. This is really similar to the way that I personally research things on the internet. I start with an initial question that usually leads me to more questions, which leads me to more questions. And then eventually I try to wrap it up and bring it all back together. So this is a really powerful methodology when building AI agents. Now, there are more advanced methodologies and other methodologies that work better in other situations. And essentially, this is really like a QA methodology. So you have the prompt that goes into the LLM, and the LLM gets an answer to it, right? And then the LLM asks itself in the next query, it says, what is wrong or what could be better about this answer? And then it gets a list of all the things it could do better. And then the LLM does another query to itself and says, okay, now with the initial answer and the list of things we could do better, let's go ahead and do a refinement phase and get a new answer. And then when you get the new answer, just start the whole process over again until we get a really high fidelity answer. And then let's return that back to the user. So in some of the tests on this, they almost get double the quality of the output just by kind of iterating through these loops and letting the L kind of think repeatedly on itself before answering. And then last but not least, there are methodologies that are less focused on language and more focused on other fields. So for example, one of the most common ones is the field of coding. So AI is used a lot now as a force multiplier in the coding space with Cursor and Windsurf and other tools like that. And this alpha codium is a methodology that came out, which really helps step through a process. And they found as part of the research here that if you go through this framework or process, you're going to get way better answers when you're trying to generate code. So, we can see that there's going to be these different methodologies and they'll continue to evolve over time and continue to help us build better and better AI agents. Let's flip over and look at the code of a really simple example here to kind of show you what I'm talking about under the hood. Okay, so in this example, we have a folder, and the folder is called suspicious samples. And in that folder, we have some ELF binaries, which are binaries for Linux systems. And we have a prompt here, and basically the prompt says, hey, I want you to go through this thought, action, pause, then observe loop, that ReAct loop that we talked about previously. You're actions that are available to you. So this is very similar to like tools or function calling. It's going to be scan with ClamAV and check YAR rules. So we have some YAR rules we can run against it. We have ClamAV we can run against these files. And then we're going to just give it an example. So this would be like a one-shot type prompt, because shot means example. So we're giving it one example, one shot. And we're saying here, okay, scan the directory. Is it malicious? Okay. No malware signatures are found. Okay, let's run the YAR rules. Detected suspicious packer. All right, return back to the user that's likely suspicious. So that's kind of the general flow that we want the AI to follow, and hopefully it adheres to this prompt. Okay, so flipping over, let's look at the code a little bit. In the code, I've just built this really basic agent class. When it initializes, it needs kind of a system prompt. And then when you go ahead to call it, you can give it the user prompt, and then it's gonna go ahead and create the client.chat.completions.create call, which is going to call out to the OpenAI APIs, and it's going to give you back the answer there, and then it's going to append that kind of as part of the message query inside of the object. Now we're going to specify a max turns. One important thing with agents is just to always make sure that it doesn't just keep processing forever, that eventually it returns you back an answer. And we're going to have a question that we're going to ask it, and here we'll see that it's going to read the prompt from the malware analysis file. It's going to change some of those default templated variables inside of the prompt file, and then it's going to create our AI agent using that custom class above, and then it's going to go ahead and give it the prompt for the question, and then it's going to kind of iterate in that loop over and over until it's satisfied or until it hits the max loops of 5 times. Now I've also coded up the same process but not using an LLM, so you could see manually how this would work. You could also see how much more code is required if you're going to manually try to step through each edge case. And this is just for a very simple example. So, you can think as you add more and more tools and you add more and more edge cases, really the feasibility of coding all of those edge cases is not realistic. Okay, so let's go ahead and just have a look at the tool real quick. We'll go here and we'll just run Python, scan all. It's going to say, hey, do you want to do this manually or do you want to do it with the AI bot? We'll do it with the AI bot. And here we see we have 5 files that we can scan. All right, so the first file is, we'll just put number 4 for 001.elf. It's going to go ahead and scan that file, and we're going to see if it's malicious or not. So you can see at first it decides, oh, I should use the ClamAV to scan it. Now we're waiting on ClamAV to give us back the results. And while we're waiting on ClamAV to get back the results, we can focus on other tasks. All right, we see the results and it says, hey, I don't have any signature for this, so I don't think that it's malicious. So then it says, okay, I'll double check with the YAR rules. The YAR rules says it's not malicious. So it comes back and says, hey, this file looks clean, looks good to us. All right, let's try it again, but with a slightly different file this time. So this time we're gonna go ahead and do 003.elf file. Now 003.elf, this actually contains the EICAR string, which is kind of a test string that AVs use to ensure that they're working properly. So basically, if you have this magic string inside a file, it's going to detect it as malicious. That way you can know that your AV is working without actually having malicious files on your system. So here we can see it detected it as infected, and then it wrote up in the description, hey, it's using this EICAR signature file, which is known to be used to test AVs. Okay. But you can also see there, because the AV said it was bad, it just skipped over the YAR step and gave us the answer directly. It decided, I don't need to do the YAR step if I already know it's bad. I'll just get the answer back to the user. Okay, last but not least, we're going to check the 004.elf file. Now, it decides it's going to run the ClamAV against the file. We should see ClamAV come back and be clean against this file. And so then it's going to decide to go ahead and check it with the YAR signatures. And then we'll see that it's going to flag or hit with one of the YAR signatures. And then it's going to return back to us that it is potentially malicious due to the detection of the Bryce is evil virus rule by YARA signatures. So you can kind of see the LLM's reasoning and thought process looping around. And if you had more tools or you had more detailed analysis that needed to be done, it might take a little bit longer. It might do some more loops. But hopefully this helps you understand a little bit better how you can build AI agents without having to use any of those frameworks that are out there. And if you're using those frameworks out there, hopefully this helps you to know a little bit more about what they're doing under the hood. So when things don't work as expected, you can kind of debug things better. All right, well, thanks for tuning in. Really appreciate it. I'm working hard to bring you new content every day. And please like, subscribe, leave a comment. Tell me what else you want to see, and I'll make the videos for you. I read all the comments. All right, have a great day. Bye.